So all the problems that we did the other day had only one battery in the circuit. What happens if we've got more than one battery in the circuit and there's multiple loops? Well, then we have to use what's called Kirchoff's laws to solve for the currents, and then we can get the voltages in each of the components. But to do that, we have to follow certain rules. So Kirchoff's current law says that the total current into any junction is equal to the total current out of the junction. And Kirchhoff's voltage law says that if you go around a closed loop in the circuit, any closed loop in the circuit, if you add up all the voltage drops, you're going to get zero. So what that means is that some of the voltage drops have to be positive and some of them have to be negative in order for multiple voltage drops to add up to zero. So how are we going to decide which is positive and which is negative? Well, what we're going to do is we're going to follow the two sets of rules in the pictures down below. So one is for the direction that you go through a resistor. So if you look at the resistor down on the bottom left, we've got the current flowing from left to right. And if I go through that resistor from point A to point B, then that's going to be a negative voltage drop. So if I go in the direction of the current, that's a negative voltage drop. In the next picture, the one over on the right, now the current is going from right to left, and I'm going to go from A to B, so I'm going to go from left to right. So if I go the opposite direction of the current, that's a positive voltage drop. So negative if you go in the same direction, positive if you go in the opposite direction to the current. And for the battery, it's a little bit simpler. So now look at the pictures on the bottom. If I go from A to B, and I go from the negative towards the positive terminal of the battery, then it's a positive voltage. If I go now in the picture on the bottom right, I go from A to B, I go towards the negative, then it's a negative voltage drop. So remember, when you look at the picture, the negative terminal is the shorter one, the positive terminal is the longer one. If you go towards the positive terminal, it's positive. If you go towards the negative terminal, it's negative. All right, so let's put all these into effect solving a circuit. So I'm going to go over to my whiteboard now, so I've got lots of room to write. So here's a sample circuit. I've got 3 batteries in this circuit, and I've got, 5 resistors in the circuit. So I want to solve for I1, I2, and I3, and I've got those labeled with the direction. If you get a circuit that doesn't have the currents labeled, just put them in, guess at the direction, and if you guess wrong, then all that will happen is that you'll get your value to be negative instead of positive. Okay, so what are we going to do? Well, we're going to use Kirchhoff's current laws and Kirchhoff's voltage laws to solve for the 3 currents. So since I have 3 unknown currents, that means I need to have 3 equations, right? You can only solve if you have the same number of equations as unknowns. So I need to get myself 3 equations. So the first equation that we always get is by using Kirchhoff's current law. So I'm going to use Kirchhoff's current law, so I'm going to abbreviate that KCL at point B. So at point B, I'm going to use Kirchhoff's current law, which tells me that the current into that junction is equal to the current out of the junction. So if I look, I've got I2 is going in. So I2 is in. I1 is going away from the junction, so that's out. I3 is going away, so that's out. So I2 is equal to I1 plus I3. If I had done that equation at the other junction is at point E, what I would have had is if I take I1, trace I1 around, I1 would be going in. I3, if I take I3 around, I3 would be going in. So I would have I1 plus I3 in, and I2 is going up that middle line, so I2 is going out. And if you look, those 2 equations are the same, right? I2 is equal to I1 plus I3, or I1 plus I3 equals I2. That's the same equation, so there's no point writing that twice. Okay, so there's my first equation. Now to get 2 more equations, I'm going to have to use 2 more rules, and the 2 more rules I'm going to use are Kirchhoff's voltage laws. So I'm going to have to do 2 different loops to get Kirchhoff's voltage laws. Let me first do a loop where I'm going to go all the way around the outside. Okay, Okay, so I'm going to go all the way around the outside from A, B, to C, to D, to E, to F, and back to A. So it's going to be an outside loop. So it's going to be A, B, C, D, E, F, A. And it always helps me to write down what I'm doing so that if I come back, I get something wrong, I come back, I can at least figure out what it was that I was doing. All right, so I'm going to go from A to B. So going from A to B, I1 is going from B to A. I'm going in the opposite direction to I1. So that means the voltage drop is going to be plus I times R. So it's going to be plus 4, and the current is I1. So the R is 4, the current is I1, and it's positive because I'm going opposite to the current. Okay, so now I'm at point B. I'm going to go to point C. Now when I go from B to C, I'm going in the same direction as I3. So now that's going to be a negative I times R. So it's going to be negative R is 6 times I3. Okay, so now I'm at point C. I'm going to go down to point D. So now I've got a battery. This battery, I'm going to go from the short line to the long line. So from the minus to the plus. So that's going to be plus 15 volts. Then I'm going to go through this 3 ohm resistor. And remember, I3 goes all the way around. So I'm going to be going in the same direction as I3. So that's going to be negative again. And my I is 3. So it's going to be minus 3 I3. And from D to E, there's nothing. So I don't have to do anything there. Now from E to F, I'm going to go through an 8 ohm resistor. The current is going around like that. That's still I1. And I'm going from E to F. So it's the opposite direction. So it's going to be positive. So it's going to be plus. R is 8. And the current is I1. And then finally, from F back to A, I'm going through that 5-volt battery towards the plus. So that's plus 5 volts. And since I'm now all the way around, I'm going to set that equal to 0. Okay, so let's simplify this. Let's go through and just collect all the terms. So I've got a 4I1 and an 8I1. So it's going to be 12I1. Let's see, in terms of I3, I've got minus 6I3 and minus 3I3. So that's minus 9I3. And then I've got plus 5, plus 15. So it's going to be plus 20 equals 0. So there's my equation 2. So I've got equation 1, I've got equation 2. Now equation 3, I've got to choose another loop in the circuit to go around. And I'm going to choose, for my second loop, I'm going to choose to go around the inside loop from A to B to E to F and back to A. Okay, so if I go around that loop from A to B, well, we already did that in the first loop. We're going through that 4 ohm resistor in the opposite direction to I1. So that's a plus 4 I1. Then I'm going to go from B to E. If I go from B to E, I'm going through the 5 ohm resistor in the opposite direction to I2. So I'm going to have plus 5 I2. I'm going to go through that 10-volt battery. Now I'm going towards the minus, so it's going to be minus 10 volts. Then I'm going to go through that 8 ohm resistor from E to F, and we already did that, right, in the other loop. So it's going to be plus 8 I1. And then finally from F to A, we're going to go through that 5-volt battery towards the positive, so it's going to be plus 5 volts. And I'm all the way back where I started, so I set that equal to 0. All right, so let's collect our terms again. So I've got 12I1. I've got just 5I2. And then if I look at the voltages, I've got minus 10 and plus 5, so it's going to be minus 5 equals 0. All right, so now I have my 3 equations. Let me draw a red box around my 3 equations. And so now I have to solve the equations. If you've taken linear algebra, then the easiest way to solve it is using linear algebra using Cramer's rule, but let me do it for you just using algebraic. All right, so the first thing we have to do is we need to get rid of one of the currents. So what I'm going to do is I'm going to take my equation that tells me I2 is equal to I1 plus I3. I'm going to plug it in to equation 3 for I2. And so I'm going to get, so let me write down what I did. So equation 1 into equation 3. So that's going to give me 12I1 plus 5. And instead of I2, I'm going to write that's equal to I1 plus I3. Minus 5 equals 0. And then let's expand that out. So 12I1 plus 5I1 plus 5I3 minus 5 equals 0. And let's combine the terms. So now I've got 12 plus 5I1, so 17I1 plus 5I3 minus 5 equals 0. So let's call that equation 3a. All right, so now what I do is I'm going to take that equation, I'm going to rearrange it so I solve for either I1 in terms of I3 or I3 in terms of I1. Let me do it. Let me solve for I3 in terms of I1. So I'm going to take 5I3, leave that on the left side. I'm going to bring all the other terms over to the right side. So I'm going to flip their signs. So get plus 5 minus 17I1 is equal to 5I3. So I3 is equal to 5 minus 17I1 over 5. If I put that into my calculator, I get that's 1 minus 3.4I1. Okay, so now I've got I3 in terms of I1. All right, so now what am I going to do? So I've used equation 1, I've used equation 3, so the only equation that I haven't used yet is equation 2. So I'm going to substitute this into equation 2. So if I substitute that into equation 2, equation 2 is 12I1 minus 9I3. So instead of I3, I'm going to put in that I3 is 1 minus 3.4I1 plus 20 is equal to 0. So now the only unknown in that equation is I1. So if I do the math correctly, I should be able to get the right number. So let's expand out the brackets there. So 12I1 minus 9 times 1 is minus 9. Minus 9 times minus 3.4, that's going to be plus. And I get 30.6 I1 plus 20 equals 0. So now let's combine the terms in I1. So I've got 12I1 plus 30.6 I1. So I've got 42.6 I1. And I've got minus 9 plus 20, so it's plus 11, is equal to 0. So I1, so 42.6 I1 is equal to negative 11. So I1 is equal to negative 11 over 42.6, which gives me negative 0.258 amps. What does it mean that the current is negative? Well, all it means is that when we drew the arrows on the circuit, if I scroll all the way up, when we drew the arrows on the circuit, we guessed wrong. I1 should have been going around the opposite way to the way that it was drawn, but that doesn't matter. All right, so we'll go back. Now we've got an actual number for I1. So now I can take that number for I1 and I can put it back in to the equation for I3 in terms of I1, and that'll give me a number for I3. So I know that I3 is equal to 1 minus 3.4 I1. So I'm just going to put in what my I1 number is. And I need to make sure I put in that negative sign or I'll get the wrong answer. I get I3 is 1.88 amps. Okay, so now I've got I1 and I've got I3. So now I can put those numbers into equation 1. Equation 1 told me that I2 is equal to I1 plus I3, so I'm just going to add those two currents. So negative 0.258 plus 1.88, and I get the I2 is 1.62 amps. Okay, so you're always going to get one equation from Kirchoff's current law. You'll get as many equations as you need to solve for the number of currents from different loops with the Kirchoff's voltage law, and then you have to do algebra to solve for the 4 currents. So going back to the PowerPoint then, the active learning problem that I want you to do today is a similar circuit. This time there's only 2 batteries, but there's still 3 different lines in the circuit, 3 different possible loops you could do. And I want you to solve for current 1, current 2, and current 3, which are in the directions drawn on the picture. If I were you, I would do Kirchoff's current law at point B, since you can see very clearly what direction the currents are. And so that will give you equation 1. So equation 1 is going to be KCL at point B. And then to make sure it's easier for me to talk to you if you have questions about it, I would do loop 2. Your equation 2, I would do a loop going around the top loop in the clockwise direction, and your third equation go around the bottom loop in that direction. But you can choose, you can do any loop you want, or you can go all the way around the outside. Okay, good luck.